Hello, this is Jeff Hamrick at Rhodes College again, and I'm going to talk one more time about how we use sampling with replacement to build confidence intervals. In this case, confidence intervals for the values of beta naught and beta 1, the intercept and slope coefficients associated with a simple linear regression model. So I have, once again, the Brigham Young University study involving body measurements and body fat percentage, and I've gone on ahead and I've regressed body fat percentage against ankle circumference as measured in centimeters. We see that there is not a particularly strong connection between body fat percentage and ankle circumference. The R-squared is 0.071 for this simple linear model. But nonetheless, we can still build confidence intervals using sampling with replacement and Fathom for both the slope coefficient, which for the true data, the original data, is 1.22, and the intercept coefficient, which is minus 9.7 or 9.2 for the original set of data. So the strategy that we're going to deploy is the same as always. We're going to right-click on the data box, and we are going to sample cases. The number of cases we sample is equal to the total number of cases in the original set of data. That's 252 for this particular study coming out of Brigham Young University. I'll turn the animation off. In this particular case, it's a confidence interval. We sample with replacement. So I'll leave this box on. I'll leave that box checked as well. And that's a collection of 252 cases that have been sampled with replacement from the original set of data. And I'm going to now impose two measures. So I'm going to compute two confidence intervals simultaneously. The first one will be the regression slope. And the formula in this particular case is ln regr slope. The x values here are ankle circumference. The y values are body fat percentage. So that is a resampled estimate of the slope coefficient. I'm going to do the same thing, regression intercept, let me call it that. And the formula for this is ln regr intercept. The x values are the ankle circumference, the y values are the body fat percentages. So I'll press OK here, and now I have two measures, and I'm going to collect these measures repeatedly. So I'm going to go on ahead and pause the video now and collect a large number of these measures, both of these measures. I'll collect 1,500 of them. When we get back, we'll do the same thing we've always done with the switch trick to compute the upper bound and the lower bound for the confidence interval. Okay, so Fathom's done collecting the 1,500 measures. As usual, I'm going to take these measures, table off of them, and in this particular case, I'm going to go on ahead and create two dot plots, one of which is for the resampled regression slopes, the other one of which is for the resampled regression intercepts. Notice that they're both approximately Gaussian, not perfectly Gaussian, but approximately Gaussian. The technique for computing the lower and upper bound is going to be the same as always. So I'm first going to plot the original values for both. The slope was 1.22 for the original set of data. The intercept was minus 9.2 for the original set of data. And if I take, for example, twice the slope, 2 times 1.22 minus an upper percentile, let's say for a 90% confidence interval, this will be the 95th percentile of the regression slopes. I get the lower bound, and if I do the same thing using instead a low percentile, I will get the upper bound of my empirical confidence interval. This is the 90% confidence interval because I'm using the 5th and 95th percentiles respectively. So that is my confidence interval for the true slope coefficient for this particular modeling context. You would do something, I won't do it right now, but you would do a very similar computation over here with the resampled regression intercepts to get a lower bound and an upper bound that would form the confidence interval for that particular regression parameter. So that is how you use sampling with replacement to create confidence intervals for beta naught and beta 1. Thematically, it is the same as the sampling with replacement technique that we have used throughout this semester.